Hey guys, I hope you all are doing good. In the last lecture, we covered the inverse of functions, and in this one, we will be covering the composition of a function, right? So let's start with the definition of a composition. A composition of a function is when you apply one function to the result of another function. So if you have two functions, f which goes from b to set c and g which goes from the set a to b, then fog, this is the representation of a composition, right? So we write it as fog, right? Composition is f bracket g of x, and g of f is going to be g of f of x. Let's try to understand what this basically means, right? What I'm trying to say is you input the value x into this function g, and whatever value comes out of this gx, input it into the function f on the outside, right? That's the basic understanding of what the composition means. And if I do gof, it basically means solve f of x first and then input that value into this function g outside, right? Now I'm going to explain this with two different ways, right? So let's try to understand this with an arrow diagram and then with a basic equation example. So let's say I have A, B, and C over here. A has the elements 1, 2, 3. B has the elements A, B, and C. And C has the elements P, Q, and R. Right? Now, I'm just going to draw random function values. So let's say this is G and this is F. 1 goes to A, 2 goes to C, and 3 goes to B. Over here, B goes to P, A goes to Q, and C goes to R, right? So now in order to find FOG, right? FOG, let's try to solve for FOG first. What is FOG? FOG basically means F G of X, right? What this basically means is input the value. This is the function G. Let's try to take a look at the both the functions, right? This is the function G. One has the image A, two has the image C, and three has the image B, right? This is the function G, and this is the function F. A goes to Q, B has the image P, and C has the image R, right? So I hope you were able to understand it. Now, let's say I need to find what is F G of 1. How do I find it? First of all, I'm going to solve G of 1. So if I just take a look at this function, G of 1 gives me 1 points to A. So this gives me, I need to find F of A in this case. And now I can cover this function and say that A points to the arrow Q, right? So A has the image Q. So F of A is going to be Q. So my final answer is going to be Q. So I started with 1. 1 goes to A, and then A goes to Q in this case. So it's kind of going this way, right? Okay, let's take a look at another example, right? Let's say I need to find the FOG of 2 in this case. How do I find it? Again, 2 goes to C, right? And then C goes to R over here. So what is going to be the answer? 2 results in the image C in the function G, and this C, when input into the function F, results in the value R. So the final answer is going to be R in this case. Right? So the basic idea is I take a value, like the basic idea of what is a composition, right? I'll try to explain it. I input a value into a function. Whatever output comes out, I input it into some other function, right? Now, this is very important when it comes to coding as well. When you're going to be writing code, if you've not started it yet, what happens is we usually make different functions where it could be that different functions help each other, right? So maybe one function is, let's say, trying to find some odd elements in an array, and the other function is trying to find all the prime numbers in that array, right? What I'm trying to say is this composition of a function is very important to understand because different functions can have different problems that they are trying to solve, right? That's my basic understanding about it. So I hope you were able to understand this arrow diagram representation. Now let's try to understand the algebra representation in this case. Okay. Okay, so let's say f of x is equal to x square plus 1. I'm given the equation f of x, and I'm given g of x is x by half. Let's say this is f is a function from R to the set of all real numbers, and g is also from the set of all real numbers to the set of all real numbers, right? Okay. Now the very basic thing for you guys to understand is the fact that when I input some value into g, right, what it does is this function g basically halves that value. So if I input 4 into this value, it is going to result in 2. If I input 8, it's going to result in a 4, right? That's what it's trying to do. This function over here, f of x, what it's doing is it's squaring the value and adding a 1 to it. So if I input the value 1 in this case, it results in 1 square plus 1, which is 2, right? So square the value and add a 1 to it, right? So I hope you understand what these two different functions are trying to do. Now if I try to find what is FOG and what is GOF. FOG is going to be f of g of x, and this is going to be g of f of x, right? Let's solve both the equations. First, in this case, I need to put x into the g, and when I input the value x into this function g, it results in x half, x by 2, so which is f of x by 2, right? What is f of x by 2? Let's try to understand this once again. Whatever value I input into this function, it does the square of it and adds a 1 to it. So what this is going to do is, this is going to square the value and add a 1 to it. So this is the final answer of what is FOG. Now let's try to understand what is going to be GOF, right? First of all, I input what is the value of f of x into this function g. So I get g of x half, sorry, g of x square plus 1, right? So if I input any value into this function g, it does the half of it, right? So when I input this value x square plus 1, this is going to result in x square plus 1 by 2, right? So I hope you were able to understand how the composition of a function works, right? Now let's try to understand the properties of a composition. Okay. So I hope you were able to understand how the composition of a function works. In a very short summary, you input a value into some function, the result you get, you input it into the other function, and this is how we basically denote it. So GOF, whatever is on the right side, you're supposed to solve that first and then input that value into the one on the left hand side, right? And this could go way long, right? So just to give you a quick idea, let's say I had GOFOH. What this means is solve h of x first, input that value into this function f. Whatever value you get, input that function into g, right? So I hope you understand how this works. Now, let's try to see what are the properties of composition, right? First property is that it is associative. Function composition is associative, that is FOGOH is equal to FOGOH, considering we can solve any of these two first. Let's try to understand how this works, right? Look, it doesn't matter that if I do GOH first or if I do this FOG first, right? At the end of the day, this entire equation is just f g h of x, right? Very important to understand. Whatever I do solve first, at the end, this is going to result in this entire equation, right? But what's important to understand is that this is not commutative, right? That is FOG is not equal to GOF. While I can change the brackets in this case, what I cannot do is I cannot change the order. So if you look at this over here, I have changed the entire order of the equation, right? Or the order of the composition. And this is not allowed, right? So this is very important to understand. Change the brackets, that is, it is associative, but it is not commutative. That is, you cannot change the order. Now, if we look at this example over here, right? We solved for FOG. It resulted in x by 2 square plus 1. and GOF resulted in x square plus 1 by 2, right? Both of these are two different equations, right? So I hope you're able to understand that it is associative, right? But it is not commutative. Moving on, I have a final note over here. For composition to be valid, range of G must be a subset of the domain of definition of F. If this condition fails, then the composition is undefined for those inputs. Let's try to understand what this basically means, right? So let's say I'm going to take the example of the function once again, right? So A, B, C, 1, 2, 3, and P, Q, R, right? Now this is a bit different, maybe, but what I'm trying to explain is just this portion, right? The final note. Okay. For a composition to be valid, the range of G must be a subset of the domain of definition. Let's try to understand this statement, right? What is the range of any function, right? Range is all the elements that have a pre-image, right? Which is they came from some value, like it was a result of some value, right? And what is the domain of definition? Domain of definition is all those values that have an image, right? They result, when putting into the function, they result in some kind of a value. That's what I'm trying to say, right? So the range of G must be a subset of the domain of definition. This is the range of G, right? A has a preimage 1, B has a preimage 2, 3 has a preimage C. Must be the subset of the domain of definition. What I'm trying to say is, in very simple words, if you try to understand it, the elements in this set B over here, which is the range of the function G. The elements of the range of the function G should have an image. That's the basic idea. Think about it, right? Let's say if I make this small change. If I make this change where 3 points to C, so G of 3 is defined, right? G of 3 is going to be C. But I don't have any arrow going from C to R, right? That means this C is not part of the domain of definition of this function F. I hope that makes sense, right? And since it's not a part of the domain of definition of F, what happens is I cannot find F of G of 3 is going to be undefined. I hope that makes sense, right? Why? Because even though 3 results in a value C in the function G, this C further has no arrow in the function F, right? And that is what this statement exactly means. Valid, for composition to be valid, range of G, this over here, must be a subset of the domain of definition of F, right? If this condition fails, then the composition is undefined for those inputs, right? So in this case, the composition is undefined for this value 3 over here, right? So I hope you were able to understand the composition. Now I'll be giving a bunch of questions and I want you guys to solve it, and then we'll move on to solve what is the sum of functions, right? Hey guys, so I hope you have solved all these questions, right? So let's start with question number 1. Given f of x, which is square root of x minus 1, and gx, which is x square minus 4, define what is f of g and find what is the domain of definition of f of g. So let's start with what is f of g. F of g basically means I need to find out g of x first and then input that value into the function f, right? So g of f is x square minus 4. So what I basically get it, I'm just going to solve the entire question in one line. I get this, and inputting the value, get x square minus 4 minus 1, which is equal to x square minus 5, right? So I hope you were able to find what is the f o g over here. If you're not able to understand what is the domain of definition, that's totally fine. I'm going to explain it, how to figure it out, right? Okay, so let's try to understand what is the domain of definition of f o g. Once again, let's try to understand the definition once again, right? Domain of definition basically means all those elements that have an image, right? Now over here, if you think about it, whatever value I get from this function g, I need to input it into this function, right? But so let's talk about this over here. Do you think there's any restriction on any numbers that I cannot input into this function? So is there any number that I input it into this value x makes it undefined, right? There's no such element, right? I can input all the real numbers into this x over here in this function gx, and it is possible, right? I can get a valid value. But if you think about it, what do you think about this function fx over here? This is a square root of x minus 1. And if you remember, when it comes to square root, the only values that we are allowed is 0 to positive infinity, right? If there's a value which is negative inside a square root, that's going to be a complex number, right? And that is going to be undefined. So my main goal is that value inside this square root should be either 0 or should be a positive value. It cannot be a negative value. That it cannot be a value which is less than 0. So think about it. How can I make this value, this entire square root, greater than or equal to 0? I have to, least value that I can input over here is 1, right? And I can go up to positive infinity. I hope that makes sense, right? If I input 1, so if I input 1, I get 1 minus 1 equals square root of 0, which is 0. So this is valid. And I can put any positive value greater than 1. So 1 to positive infinity is the valid values I can input over here. So what should be the result of these values that I'm allowed to get? Basically, this entire result, x square minus 4, now if you think about it, in this I can put a value which is 1 to infinity. That means the result that I get for the gx, right, has to be greater than or equal to 1. Let's try to understand this once again. My main goal is I can input any values in this function gx, but I cannot input all the values into this square root function because it cannot allow negative values inside it, right? So what are the values it can allow? It can allow all the values from 1 to positive infinity. So if that is what it can allow, that means this value, the result of the gx function that I input, should be greater than or equal to 1. If that's not the case, then I'll be inputting a negative value inside this function, and that would result in an undefined value, right? So what's the result I get? I get x square should be greater than equal to 5, and x should be greater than equal to square root of 5. So my domain of definition is going to be square root of 5, comma, positive infinity. This representation basically means all the values including square root of 5 up till positive infinity, right? Okay, so I hope you were able to understand this question. Moving on, let's try to solve question number 2. Given f of x is equal to x plus 3 and gx equals 2x, evaluate FOG and GOF. So what is FOG? FOG is equal to f of g of x, right? So this is going to be f of 2x, which is going to be simply 2x plus 3. And what is going to be GOF is equal to g f of x. This results in g of x plus 3, and the final answer that I get is 2 of x plus 3, right? Okay, so I hope you understand how this works, right? When we have this equation or the form FOG, that means input the value into the g first and then input it into the function f. And in GOF, basically what's on the right hand side, you're supposed to input into that first and then go towards the left hand side, right? So this is basically the answer to this question. Moving on, let's try to solve question number 3. Let f of x equal 1 by x plus 2 and g of x equals x minus 2 by x plus 1. Find the explicit formula for f o g of x. Now, what it means by the explicit formula is simply that it wants me to basically find a entire formula for this entire equation, right? Like, so what I'm going to do is, I know f of g is equal to f of g of x, right? In order to find the entire formula, right, I'm going to input this value, this entire thing, and replace it with this x over here, right? So what I get is, I get f of g equal 1. I'm going to write this divide sign over here. It just makes things a lot more clear, right? So 1 divided by x plus 2 gives me 1 divided by, now I'm replacing this x with this value over here. So I get x minus 2 divided by x plus 1 plus 2, right? Now I'm going to take the common denominator, which I get 1 divided by x plus 1. So this gives me x minus 2 plus 2x plus 2. So I hope you are able to understand how I'm solving this equation, right? Basically took the common denominator x plus 1, solved for x minus 2, and then added, multiplied this value with the 2 over here, right? So I get 1 divided by, this 2 cancels out, x plus 2x by x plus 1. So I get 1 multiplied by x plus 1. Think about it, right? When it basically means divide, then I'm supposed to reverse this down, right? So I get 1 multiplied by x plus 1 by 3x. So my final answer is x plus 1 by 3x. So I hope you are able to solve all these questions. Inverse and composition are pretty simple concepts, but it's very important to solve as much questions as you can, right? So I hope you were able to understand it. Moving on. In the next lecture, we will be covering the sum of functions, right? So I'll see you guys in the next lecture.